Chess is one of the oldest and most popular games in the world, widely considered a great test of human intelligence, intuition, and calculation. Its rules are incredibly simple, however, it's amazingly difficult to master. Since the invention of the modern computer, scientists have wondered if it's possible to build a machine smart enough to beat humans at their own game. And if such a machine can be designed, what can we learn from them? We begin in 1948. Alan Turing, an English mathematician and computer scientist, believed that a computer program was capable of competing against humans in chess. That year, he wrote a crude algorithm called TurboChamp that was able to play a full game against his friend, thinking 2 moves ahead. The algorithm lost in 29 moves, but marked the start of AI playing chess. A year later, in 1949, Claude Shannon, an American electrical engineer, wrote a paper programming a computer to play chess. That became the benchmark for how artificial intelligence was designed to play chess moving forward. In it, Claude describes the principles in which a computer chooses a move. The computer would evaluate the pieces on the board, also known as the state of the game, and calculates a number. The larger the number, the more favored is white to win, and the more negative the number, the more favored black is to win. Using this number, the computer would deploy an algorithm called Minimax. The nodes in the tree represent different states of the game, and each row alternates, demonstrating which player is making the move. The algorithm also assumes that each player will choose the move that benefits them the most. The algorithm first looks at the bottom leaf nodes, evaluates the state on the board, and assigns a value to the nodes. It then moves up one layer and looks at another node, and depending on if the level is trying to minimize or maximize the score, it sets the value to the lowest or highest value respectively from its branches. This represents the AI choosing its next move from that position. This process repeats each layer all the way up the tree, and by the end of it, the program knows at each state what move to pick. The algorithm has one major flaw, however. There are 10 to the 120 possible games of chess that can be played. That is far more games than there are atoms in the universe. This means that it is impossible for a computer to evaluate all the positions using this algorithm. It can only look at a handful of moves ahead before it reaches the limitations of memory. This leads us to 1974 and the Soviet AI called Kaysa. Kaysa used the same Minimax algorithm but introduced a new feature called pruning. This is a mathematical concept that eliminates some branches from the move tree that are clearly worse than other options. This means that it was able to spend more time evaluating promising moves rather than waste its time exploring countless other positions the game may end up in. Kaysa also introduced a set of pre-programmed openings, an algorithm for time management, and several other features that improved its performance. Fast forward to 1997. A team at IBM had created a computer called Deep Blue. Deep Blue is very similar to Kaysa. However, with the advancement of computing power, it was able to calculate 100 million positions per second. And with this, the computer was finally ready to take on the best chess player in the world, Garry Kasparov. Deep Blue faced off against Kasparov on May 3, 1997, playing a 6-game series. Deep Blue won 3.5 points to 2.5. This was the first time a computer had beaten a world chess champion, and officially marked AI as better than humans at chess. Computers have only gotten smarter since, with AI such as Stockfish being far beyond the level of any human. Chess engines such as these have become the learning tools of new chess players, allowing them to refine their strategies and evaluate their own games unlike ever before.